All right, so we are going to start linear algebra. This whole playlist is going to be following a first year university linear algebra course. It's not going to be exactly the same, but it should help you along your way. First of all, what even is linear algebra? Well, linear means lines, and algebra means a relationship or equations. We're really going to be focusing on lines like this. So if you see the blue one that goes up, it's just a straight line in 2 dimensions. Now, if it were in 3 dimensions, it would look like this yellow one, or the green, or the gray. For us to be able to simplify our lives, things like matrices and vectors have been invented, and those are really organizational tools to help us represent certain things. This will hopefully make sense a little later on. Now again, a linear function, it's a straight line in 2 dimensions and it's flat in 3 dimensions. It has the equation y is equal to mx plus b. M is the slope and b is the y-intercept. So really quickly, which one of these is linear? Well, I just told you it's y is equal to mx plus b. That's this one right here because it is in a straight line. This one, it's a parabola, not straight. This is not straight either, all right? So before we go any further and start talking about matrices, we need to know how to solve systems of linear equations. When somebody says they want you to solve a system or find the solution, they really mean that they want you to find the variables. So if you look here, we want to know what y is and we want to know what x is. Let's take this first example. If you want, you can pause the video, try this out by yourself just to get a refresher. So we have 2x plus 3y is equal to minus 8. Then we have x minus y is equal to 6. So I just wrote them out here. I have my 2 equations. The first step is going to be to isolate one variable. It's easier to do in this equation. I don't have to pick it, but I decided to. So I isolated x and I got x is equal to 6 plus y. And I'm going to take this value of x, and I'm going to plug it in to this equation up here, which is what I did. So 2 times 6 plus y plus 3y is equal to negative 8. And then I just do some simple algebra, and I get y is equal to negative 4. I then can take any of the first equations, plug in y is equal to negative 4, and I come up with x is equal to 2. So where matrices really come into handy is when you have lots and lots of these equations. So let's say you have like 10 equations and you have to find all 10 variables. You're going to put it into a matrix. So matrices is just a plural of matrix. Here, I will explain this in the next video, but I have organized some systems of linear equations into 2 rows. So this is 1 row, this is another row, and 3 columns. So 1 column, 2 columns, 3 columns. So I call it a 2 by 3 matrix. Rows first, column second. It is also represented by m times n. So m is the rows, n is the column. Why do we need them? Well, it's going to make our life a lot easier. This whole second part of this playlist is going to focus on vectors. Now, if you've taken a physics course, maybe you've heard of this before. So vectors, they're just a straight line. What's special about them is that they have a magnitude and a direction. If you look at this little a here, you're going to see the arrow on top of it. That means it is a vector. It is pointing in a direction. Okay? So we can add vectors up. We can multiply them by a scalar. A scalar is just a normal number, so like 1, 2, 2 halves, things like that. But we cannot multiply them just normally by another vector. We're going to see how to do stuff called a dot product later on. That's not for now. And there are many different kinds of vectors, a lot of different ways of representing them. So don't just think that there's only like one specific way you're going to see it, because it might come up and look like a polynomial. It might just be a number. Okay? But something to look for is this little arrow on top of a letter. So in the next video, we are going to be talking about the matrix and row operations. So I'll see you then.